Alright, thank you for joining me. In this problem we're going to be working through is we're going to find the region bounded by y equals natural log of x squared, x equals 1, x equals e, and y equals 0. And we're going to create a three-dimensional object by revolving that object around the y-axis. And what we want to do is we want to be able to find the volume of the object. So now in order to do that, the first thing we need to do is we need to graph this region, figure out what that looks like. Alright, so we graphed those out. We have natural log of x squared here. We have x equals e, y equals 0, and x equals 1. Notice that the natural log of x squared and x equals 1 and y equals 0 all meet at one point. So when we're talking about the region bounded, we're going to talk about this region right here. So that would be between x equals 1 and x equals e, underneath natural log of x squared. Now, what we're going to do with that is we need to project that into a three-dimensional space by revolving around the y-axis. So again, we're going to rotate around. I'll keep my thumb fixed and I'll pivot my other finger around. Everything that hits is what we're going to end up with. And so if we do graph this, what we're going to get is something that looks like this. And then we can spin around and get circles. And then if we draw down here, we're going to get something that looks like this. And so what we end up doing is we have an outer shell, which will be having an inner shell cut out. And so we're going to end up with something where we have an outer cylinder with a portion cut out. So that's what our object's going to look like. What we need to do now is we need to find the total volume. So in order to find the total volume, we're going to go ahead and cut cross sections out. And now if we want to cut cross sections here, we have two options again, is we can cut out shells or we can cut out washers. And shells we would be moving left to right, washers we would be moving up and down. And so the one that you want to use is the one that you're more comfortable with. I'm going to use washers here because I used shell in the last example, so then I can give you an example of each. So now if I cut washers out here, what that's going to look like is I'm going to have a cross section that looks like this, and then I will cut the inner portion out, and so I'm going to get something that looks like that, and then I'm going to have this cut three-dimensionally so that I get that. Alright, so now we can imagine that that looks like a cylinder with another cylinder cut out, where we're going to let this get as thin as possible in order to add up those volumes of the cross sections. So now, if I want to find the volume of that cross section, what I'm going to do is I'm going to say it's going to be the area of the face times the depth. So the area of the face times the depth. And the area of the face is going to be, well, if I imagine looking at this head on, it's going to look like this. And I want to find this area here. So the way I'm going to do that is I'm going to find actually all of the area. So all of that area. And then I'm going to subtract off this smaller area in order to be left with just the blue area. So now the bigger area is pi times my bigger radius squared because it's a circle. And then I'm going to subtract off my smaller area is pi times my smaller area, or radius squared. And then I'm going to multiply that by the depth of this cross section. So what I end up with is the volume of my cross sections are pi times big R squared minus pi times little r squared times depth. And what we need to do is we need to find each of those. And so I'm going to start with depth. Now, if I look at the depth, that's going to be this distance here. Notice that we want that to be able to change because we're going to want that to get smaller and smaller. So we're going to call this our change in some variable. Since we're moving up and down, we're moving in the y direction. So we're going to call it delta y. So that is our depth is delta y. Now, if we look at our bigger radius corresponds to this value. Our smaller radius corresponds to this value. So what we're going to get here is that the bigger radius corresponds to an x value, or a bigger x value, and the smaller radius corresponds to a smaller x value. So we'll get pi times the bigger x squared minus pi times the smaller x squared, all times delta y. Now the point is, because our depth is delta y, we have to have the bigger and the smaller x values in terms of y so that we can end up integrating, so we have to find those values. Now if I look at the bigger x, notice that that actually stays constant, and what we're going to get there is that the bigger x is just equal to e. So I can substitute that in and I can get pi times e squared. Now my smaller x value is going to be the x value that corresponds to this function. So that is x when y is equal to natural log of x squared. So what I have to do is I have to let y be natural log of x squared, and I have to solve for x. So in order to solve for x, I'm going to say e to the y is x squared. So then x is the square root of e to the y. And I'm going to leave it like that for now. I can simplify if I want, but I'm going to end up with squaring over here, so that's going to be okay. So I'm going to get pi times the square root of e to the y squared, all times delta y. And as I said earlier, this does simplify to, I'm going to go ahead and factor out the pi, and I'm going to get e squared minus e to the y delta y. So now that I have my bigger x and my smaller x in terms of y, and my changes in terms of y, what I can do is I can find the total volume by adding up all the volumes of the cross sections. So I'm going to say that my total volume is the integral from a to b of pi times e squared minus e to the y dy, where I'm using dy instead of delta y because my change is getting infinitesimally small. Alright, now the next thing I need to do is I need to find a and I need to find b. So what is the smallest y value I'm interested in, and what is the largest y value I'm interested in? Well, the smallest y value we're interested in is actually given to us. That's y equals 0. The largest y value we're interested in is the intersection of this function and this function. And so what we get is it's the intersection of y equals natural log of x squared and x equals e. So if we let those two be equal, what we get is y is equal to natural log of x is e squared. So we get y equals 2. Therefore, if we want to find the total volume, we're going to integrate from 0 to 2 of pi times e squared minus e to the y dy. Now, in order to find that, we would just integrate. We can do that if we'd like, but again, we've done a couple examples of integration before, so I'll let you refer back to those on how to find those definite integrals. But for now, we have set up, and the integral, in order to find the area, all that's left now is to evaluate. So this would be a setup, but do not evaluate problem. Alright, thank you for joining me for calculus practice. If you'd like to see more problems, you can check out the rest of this playlist available up here. Also, please sure to subscribe to the channel so you can see when we have more of these coming up. In addition to that, you can also check out the link available in the description below to see the written version of each of these problems so that you can pull that up to follow along with the video or to do on your own for extra practice. Thank you and good luck with your studying.